Hello everyone and welcome to my presentation where I will be showing you how to deploy your Gradle Java project into Kubernetes using Eclipse JKube. My name is Mark Nuri and I work as a software engineer for Red Hat. I'm currently working on two open source projects, the Fabricate Kubernetes client and Eclipse JKube. You can find me almost everywhere, so please, if you have any questions regarding today's session or you think that I can help out with something else regarding the project, don't hesitate in getting in touch with me. On today's agenda, this is the agenda for today. I will start with an introduction. I know there's lots of people in EclipseCon with very different backgrounds, so what I want is to make sure that we're all on the same page. I will start by describing the way that people are building container images and deploying their applications today, and what are some of the challenges that they might be facing. And I will also show you how JKube can help you overcome these challenges. I will give you a small overview of what JKube is, the components and the configuration modes. And then I will jump into describing the new Kubernetes Gradle Plugin and a very short demo on the new tasks that JKube provides for us. Finally, I will show you, I will give you a few reasons on why you should use Eclipse JKube instead of some other alternatives. And finally, an overview of the roadmap for the next weeks and months. So I guess that this diagram should be very familiar to most of you. It describes what was the workflow to deploy applications, or the traditional workflow. You start with some Java code, and then you run a build process, and you generate an application package. It could be a fadjar, a war, whatever. You would get this package and hand it to your operations team, and they would deploy it into a production server. That the server would include the operating system, a Java runtime environment, an application container, whatever. And they would make sure that your application would run. So probably many of the tasks that are in this last step, as a developer or as a Java developer, you never had to deal with them. However, the paradigm has changed, and now the de facto way to deploy your applications is Kubernetes. And many of these tasks and the infrastructure are now moving to the left. So now, instead of shipping an application package, you need to provide a container image, which includes the container operating system, the Java runtime environment, and your application package. So you need to now maintain this container image. But in addition, you also need to provide and maintain some cluster configuration manifests. So amongst many of the new challenges that you have to deal as a developer when deploying applications to Kubernetes, one of the important ones is having to generate your container images and your cluster configuration manifests. So in order to generate a container image, the traditional approach is usually with a Dockerfile. A Dockerfile is just a recipe or a script that will assemble your container image. In this particular example, I'm provisioning an operating system with a Java runtime environment. I'm setting the user, then I'm copying the application package into the image, providing an environment variable, and then an entry point. In addition to this, you also have to run certain commands to build your application and to push it into an external registry. So we already have a dependency in an external tool, in this case, Docker. So as the complexity on your application keeps growing, the Dockerfile will get longer and longer, and it will become harder to maintain and will probably be a source of bugs in the future. So that's dealing the container image, but you also need to provide some cluster configurations, in this case, the YAML file. So if you want to deploy an image into Kubernetes, you will probably be needing a deployment, a service, config map, maybe an ingress, maybe a secret, and you will have to maintain and create also those cluster configurations. In addition, you will also need to deploy those configurations. So you will need an extra tool too, another external dependency. In this case, I'm using kubectl to create the resources in my cluster. So probably, as a developer, what you want is a tool that will help you abstract away the implementation details when you are dealing with the YAML files and the container and generating your container images. And even better, something that could infer all of the configuration for your application for you. And obviously, this tool is JKube, which is the one I'm presenting today. So what is JKube? JKube is a set of tools and plugins that will help you generate container images and generate and deploy the configuration manifests in Kubernetes. It consists of several components. The best component is the Java API, what we call the JKube kit, and on top of that, we provide several plugins that make use of and expose this Java API. The Kubernetes Maven and Gradle plugins should be used when you are dealing with a Kubernetes cluster. And on top of that, you have the OpenShift Maven and Gradle plugins that are extending the Kubernetes plugins and can be used when you are dealing with an OpenShift cluster. It will provide OpenShift specific features such as S2I builds or support for OpenShift specific resources. Regarding the build strategies, I won't go into too much detail, but we currently support 3 different build strategies: Docker, S2I, and Zip. And the cool thing about JKube is that it abstracts away all of the configuration for your image. So basically, just by providing a configuration flag, you would be able to switch from one build strategy to the other. You won't need to provide specific configuration for Docker or S2I. Regarding the configuration modes, JKube starts with this 0config. JKube has a strong set of opinionated defaults and support for many frameworks and technologies. So what it basically does, it analyzes your project and it infers the configuration for you. It will generate a container image and some cluster configurations that should be suitable for your application. Obviously, in many cases, these opinionated defaults won't be enough for you, or you would want to modify at least certain parts of this configuration. So that's pretty easy. Depending on if you are using Maven or Gradle, for Maven you can use XML and you could be able to configure or override these defaults by providing XML in your POM XML file. For Gradle, you could use the Gradle DSL, and in your build.gradle, you could provide these additional settings in order to override some of these defaults or to provide fully manual configurations. You could also use Maven or Gradle build properties to override some of these defaults. You could even use these properties in the command line when you are executing some of the goals or tasks. Finally, we also offer what we call resource fragments, which is a very powerful way to modify the configurations that we generate. So basically, what you can do is provide a partial fragment of a YAML file, maybe a little part of your deployment or the config map or whatever, some small fragment of that configuration. JKube will read that fragment and it will merge it with the configurations that it will generate with the opinionated defaults. So it's a very easy way to override some of these configurations. So yeah, what if I told you that regarding your Gradle project, you could get those Dockerfiles or those YAML files, throw them away, and just by adding a plugin into your project, you would be able to deploy that application into Kubernetes. That would be really cool, right? So this is what I'm going to demo today, and I will also showcase a few of the Gradle tasks that are already available in the Kubernetes Gradle plugin. So in today's demo, I'm going to show you the Spring Boot Pet Clinic, but in this case, I'm going to use the Gradle plus Kotlin flavored version of the project. So this is the Pet Clinic, and well, it's not the original one. It's the modified version that uses Kotlin and Gradle instead. Okay, it's fairly popular, and yeah, I think it's a good example for me to show you how powerful JKube is. I already have a cloned version of the project in my IDE open, but I haven't modified anything. This is just to speed up things for the demo purpose. So the first thing that I'm going to do is I'm going to remove the Docker files that are provided in the project by default. Okay, so this won't be necessary when using Gradle. Next step, I'm going to add the plugin into my build.gradle. So I'm adding the plugin reference here, and I'm going to add a few properties to override some of the defaults that we talked about before. Okay, so Let me copy this. Okay, so the first one is I'm going to overwrite the name of the image. I'm going to deploy, to push my image to my Docker Hub account. So in order to do this, you need to use a specific image to use this repository, because I don't have, obviously, permissions to push anywhere. So I need to overwrite my image. I'm also going to force the deployment to always pull the image. And finally, I'm going to instruct JKube to generate external URLs for us, which means that it will generate also an ingress when it's generating the resources. So now that the project is ready, what I'm going to do is I'm going to build it. This is the usual Gradle build, nothing new here yet. And now it's the time to build my image. Okay, so I'm going to use the k8s build task. So as you can see, it was successful. It's using my local Docker daemon. And if I check my images locally, I have a new image that was created 9 seconds ago. Okay, next step would be to push this image into my Docker Hub registry. So there's no image here. And once the process finishes, the image should be available here. It takes a little while. Let me see. Okay, so the task was successful. And if I check, a new tag was created a few seconds ago. So it's already available here. Next step, I'm going to generate the resources for the application, the cluster configuration manifests. In this case, I'm going to provide a property, a build property via the command line. And I want to overwrite the domain for the ingress, and I want to use the Minikube IP. Since I'm going to deploy this in my local Minikube cluster, I want to override this in order to make the ingress work. Okay. So if I run this, it generated a few resources, and I should be able to see them here. Okay, so JKube generated for us a deployment. So if we check the deployment, we can see that it's quite complex. It added a few annotations, some labels to identify our application, the name, the replicas, and so on. It's also generated the pod template and the spec. It added a few environment variables that might be useful, the name of the image that we configured, the pull policy, which is always as we declared in the Gradle properties, and it also added a liveness and readiness probe. Why did it add this? Okay, JKube is smart enough, and it checked the project dependencies, and since we have the Spring Boot actuator, it knows that the application is exposing these endpoints in order to check the health of the application. So it created these probes for us. In addition, it created a service. The service, again, contains the labels and so on, and it also inferred the application port. It reads it from the application properties. So also some configuration that gets out of the box for you. Finally, it generated an ingress for us. So it's using the domain that I requested when running the command. So the final step, I'm going to deploy this into my Minikube cluster. So this is the view of my cluster right now. There are no resources deployed with the Spring name. So if now I run the Gradle k8s apply, the resources should appear here. Okay. You see they were deployed. The status for the pod is pending. It's now downloading the image from my Docker Hub registry. And it's also marked unready. It's already running, but it's unready. Why is it unready? Because we have this readiness probe, and the Spring application takes a while to start. In the meantime, we can check the log of the application running in the cluster. This command, this Gradle task, Gradle k8s log, will tail the logs. So it shows you that started the application, and it should give a further message Okay, completed initialization. As you see, now the application is marked as ready, and we should be able to check. As you can see, the application is now working. We are accessing through the ingress. It's working. We can find an owner. We can visit it. So everything is working okay. We are tailing the log. If you know the Spring Pet Clinic application, you know that there will have this error button that will trigger an exception. So if I press this, I should be able to see the exception logging here. Let me press it. Okay, and as you can see, we tailed the exception too. Okay. So let me also show you an additional development tool task, which is the debug goal. And this will allow us to debug the application in the cluster. So what I'm doing now is telling JKube to restart the application in debug mode. And what will happen is that the deployment will start, will be replaced with one that has an environment variable that instructs the container to start in debug mode. So the initial pod is being replaced by a new one. And once the new pod becomes ready, again, the readiness probe, we will see a message here indicating that we can start the debug process. It should be ready in a moment. Okay, now it's ready. And as you can see, we see a message that shows us that we can already start the debug session. To start the debug session, I'm going to add a remote debug session here. And I'm going to use the 5005 port. Again, these instructions, you can find them in the log here. So debug, okay. And I'm going to add a breakpoint. So there is this owner controller here, and okay. I'm going to connect, and I will add the breakpoint here. It's been submitted. So now, if I check one of those owners, my IDE should stop in the breakpoint. So it stopped here, and now I should be able to set, for example, or replace a value here. Let's use so if I resume the execution, now we've replaced the value on the container. So really, really good and cool feature that we can actually debug the application running in Kubernetes. Finally, the last task I want to show you really quickly is the undeploy goal. Also good for developers. We created a few resources during the demo. So what I want now is to clean this up. I run this, and the resources should be eventually deleted. Yeah, everything was deleted now. So yeah, you can see that it's pretty cool. Let me get back into my demo. Okay. So you've seen how easy it was to integrate JKube or the new Kubernetes Gradle plugin into an existing project. But let's see some additional reasons on why you should choose JKube instead of another alternative. The first one is that it covers the complete workflow. So you might find other tools that will help you generate container images, and maybe other tools that will help you generate cluster configurations. But JKube covers the full cycle. It will help you generate both things. It's also suitable for the inner loop. So you see that we have some tools for developers. We saw the K8s debug goal, the log goal, etc. And it's also suitable for the outer loop. You can generate your container images, and it can also push them into external repositories, which is something suitable for production. It can also generate Helm charts and push those Helm charts into external registries too. So it's really good for the outer loop. So it covers both. Another cool feature is that it doesn't depend in any external dependencies. You don't need to install any CLI tool or whatsoever. It will work just by adding the plugin, the Gradle plugin or the Maven plugin. It's the Java way, right? We provide these Java plugins, and it allows you to configure the image generation or the cluster configuration generation in a way that is familiar to you. Okay, and we also have this zero configuration mode. As you saw, JKube can infer many settings for you, so you don't need to provide manual configurations. It works everything out of the box. Okay, so regarding the roadmap, what you saw today was the preview of the Gradle plugins. They are still not feature complete, so as to compare to the Maven plugins, they are still lacking some stuff, but we will be completing all of these features in the coming releases. We also want to improve the Helm chart generation and add additional build strategies and support for more frameworks. What we really want is for you to get involved and provide feedback on what you want to see next. And also, we are eager to get feedback on what do you think about the new Gradle plugins. Okay. So thank you very much for joining my session. There will be a Q&A session next. So please, if you have any questions, don't hesitate to ask. And if you don't have time or you can't stay, please reach out to us with through our regular communication channels. We'll be glad to help you. Thank you very much for joining. Bye. Okay, so I don't see any questions. Okay. Okay, so can I use JKube with OpenShift, or will this only work with Kubernetes? Well, you can use both plugins with OpenShift. Basically, with the Kubernetes Maven plugin or the Kubernetes Gradle plugin, you can target any vanilla Kubernetes cluster, and also an OpenShift cluster, since OpenShift really is Kubernetes on roids. If you want to create specific OpenShift cluster manifests or resources, then you can use the OpenShift and Kubernetes Gradle plugins and Maven plugins. I don't know if there are any other questions. Okay, so I don't think there are more questions. Thank you very much all for joining. I hope you enjoyed the demo, and please, as I said, any feedback is really welcome. So please reach out to us in case you have any more questions or things. Thank you very much.